If you have ever dreamt of having superpowers and able to see through walls, then this device might be able to help you, but just not in the way that you think. Your Wi-Fi doesn't send data through wires to your devices. It sends it through radio waves. Radio waves are also able to pass through things like glass, drywall, and doors fairly easily. Every wall, but in this case a person that interferes with that signal, reflects a little bit of the signal. Signal that reaches your device is different from the one that left the router, and you can measure or read that difference. This is where the device called the ESP32 comes in. It's a microcontroller with a built-in Wi-Fi radio. With it, you can download some software to be able to read something called CSI, which is channel state information. It is able to log how the signal was changed on its way to the device. Movement causes changes in the signal, and the ESP is able to detect motion just by looking at the changes in the Wi-Fi signal. Now, what I'm building isn't smart. There are far better tested and researched ways to do this. Some companies use different Wi-Fi chips and strongest antennas to train models to recreate a 3D figure and not just a blob, or in this case, a laser that you can actually see. You can integrate that into a screen for your eyes to see. You can train models based on how the material interacts with the signal, so you're able to distinguish between metal, wood, brick, glass, and have a fully X-ray-like vision that you can see through walls. Now, there is so much more that you can learn about this topic, and I recommend taking a look if you're interested in learning more, but for now we're just making a dumb version of this. To begin, you will need a router. I bought a cheap one since the one I used for the internet is far away and through multiple walls, so it wouldn't work as well. Now you may be thinking, well, doesn't it need to be connected to the internet to send data? Yes and no. If we plug in the router on initial setup, there will be a spike in packets, and after a couple of seconds, nothing, as it's not connected to the internet and something like a video isn't being sent through. Now what you can do is tell your ESP to tell your router to send packets in controlled waves, so now you are in control of those packets. I'm going to save you some time and tell you to buy your cables that have transfer data and power, and not just power, because it'll make everything much easier, and then you'll be able to start building your project right away. But not too fast, because you probably also have to download some other stuff, so be sure to do that as well. Initially, I was going to borrow a complete build from Steven here, but my computer was not having that, so I took it from someone else. Changed very few things as I am no coder, and eventually got somewhere that I was happy with. I have no idea if this is working. Let's go over here. Can it still read the detection? Hi, Bear, what are you doing? Oh, big doggy. What about outside? Alrighty. Let's see if it worked. So what does all this code mean? This board is sitting in the hallway, and it's doing something in the background. Every 100 seconds or so, it's firing off tiny harmless packets toward the router. It's not asking for web page, it's not checking emails. It's just basically tapping the signal on the shoulder to keep it awake. Because without traffic flowing, there is nothing to measure. Each time that packet bounces back, the board pulls something called CSI, channel state information. It's a way of looking at like a snapshot in time of the Wi-Fi signal, how it got bent, bounced, and scattered all its way across the room. Walls, furniture, air, and it leaves your fingerprint everywhere. When nothing's moving, that fingerprint barely changes. That steady pattern becomes the baseline. The baseline is there to say, hey, this is what a room with no motion detected looks like. But the moment a person walks through, their body absorbs and deflects part of that signal. The fingerprint shifts. In a second it shifts past a certain point, the board flags it, and the motion is detected. Then once that is done, you duplicate the code for your other ESP node, and you have a master code called HAT, which will live on the device itself. Once the codes are flashed and everything is working, it's time to build the device itself. When the node sends detection, it will send it to the HAT. The compass compares my heading to where the motion happened. Then we have the DF player that plays a directional sound left, right, or center, so I know which way to look. Next, the speaker will play that sound back so I can hear it, and finally the laser will turn on or off based off the motion so I can visually see it. After finding all the pinouts and wiring everything together correctly, you eventually get something that looks like this. All that's left now is to solder everything together and make sure that you're not going to short circuit something. And if you haven't seen my other video, which if you so kindly would, I am no expert craftsmanship. but it does work, and that's all I really care about. I think here's a good time as ever to ask if you like this video so far, let me know. If you don't, also let me know. I like creating videos, and not just electronics, but I like music, cars, bikes, whatever it may be, and if you want to support that, that would be much appreciated. Now, in order to simulate the real thing, I'm going to have to move my router outside of my room, because before it was just detecting me moving it, since between the 3 nodes it's a triangle, so it's just detecting that small space. But having moved it and the nodes separately, it gets a more accurate reading of the hallway and the living room. Now, as you can see here, my Mac Mini is going to be just powering this thing, and it's attached to a 10-foot long micro USB cord, so that's about as far as I can walk. I didn't put any other power source into it because I didn't really think about it, nor did I want to actually handle all of that. Now here I have switched over to a camera I had, so you can see what it looks like. And since we have moved the router and nodes, it is no longer detecting my movements, but movements of things that I have around the house, or people. Now some of you may be thinking, what is the purpose or even utilization of this? Well, mostly defense. This is not a real gun, it is an airsoft BB gun that is made to resemble the weight and feel of a Glock 25, or maybe another one, I don't remember. Now specifically, this is just for a demo. Now, tech like this specifically, the research and application of RI sensing is already a field that is being partnered with many different people and groups. As you can see from C-Sail's own website, which is MIT's research laboratory, their partners are, well, they aren't very human focused.
They've alleged that you've eliminated safety inspections, that there are fewer in quality and there are fewer inspectors doing quality inspections out there. They've alleged that when they raised quality issues and concerns, they were reassigned, they were retaliated against, they were physically threatened. That doesn't sound like attention to quality to me. And yet you're getting paid $33 million a year. It's extraordinary.
Senator, I
Profits over everything, baby. I made this video because I wanted to know how easy it is to make something like Wi-Fi sensing and how much more it would take to protect the average person. Or better yet, a way to stop RF sensing, since jamming is illegal, apparently.